Hello out there, welcome to this tutorial on linear inequalities in two variables. In this video, we'll be looking at graphical method. If you are joining us now, check the description section of this video on our YouTube channel to get the link to the playlist containing all the videos on inequalities. So we start with the first problem. Problem 1. On the Cartesian plane, show the required region represented by the following inequalities: y greater than -2, x greater than or equal to -1, and 3x plus 2y less than 6. In this problem, we are going to translate each of the inequalities into equation. Thereafter, we will now plot the lines. Then will show us the required region and the region that is not required. So we start with y greater than -2, and that will give us y is equal to -2. And for x greater than or equal to -1, will give us x is equal to -1. And finally, 3x plus 2y less than 6 will be 3x plus 2y is equal to 6. This y equal to -2 is a straight line already, and x equal to -1 is also a straight line already. But 3x plus 2y equal to 0, we need to get 2 points to enable us get the straight line. At least 2 points are required to get the straight line. So before then, we create a table of values for the equation here. So we have the table. This is x and y. Then we are going to employ the method of intercept form to get the 2 points. So we choose when x is 0. So when x is 0, we have 3 times 0, which will give us 0. We'll be left with 2y is equal to 6. At that point, dividing both sides by 2, y will be equal to 3. So we have y equal to 3. And also, when y is equal to 0, 2 times 0 will give us 0. Then we'll be left with 3x is equal to 6. Dividing both sides by 3, you have x to be 2. So we've gotten all required to draw the graph. So we now have the graph here. Then we are going to calibrate. We have the x-axis, the y-axis. The point of intersection of x and y-axis is the origin. So to this place, I label it 1, 2, 3. And to the left, I have -1. And to the positive side of y, I have 2, 4. And to the negative part, we have -2. So on the x-axis now, I have used the scale of 2 centimeters to represent 1 unit, while on the y-axis, I have used 2 centimeters to represent 2 units. Then we get our point. Starting from y is equal to -2, the line is going to be a broken line because the inequality represented there is just greater than, not greater than or equal to. So if it is greater than only, then we use broken line. If it is greater than or equal to, as in x greater than or equal to -1, we use the normal bold line. So we are using broken line. So this is the line y equal to -2. So we draw the line with broken line. So from the inequality, y greater than -2. So the greater part of this line is the upper part, while the lesser part of the line is the down part of the line. So since y is greater than -2, we are interested in the upper part. So we are going to shade the parts we are not interested in. Since we are interested in the upper part, I will shade the down part, which is not the required region for the line y greater than -2. So for the next line, we have x is equal to -1. Then we check the respective inequality, which is greater than or equal to. We are going to use the normal line, not the broken line. So we use the bold line, and this is the line x is equal to -1. We now draw the line here, x is equal to -1. So we are there. Then since it is greater than, for the straight line on x axis, so which is always parallel to the y axis, the right hand side is the greater than part, while the left hand side is the less than part. So since we have greater than or equal to, so we are interested in the right hand side. So we are not interested in the left hand side. So we shade the left side of x is equal to -1 to represent the actual inequality, x is greater than or equal to -1. So the region here is the required region. For the third line, which is 3x plus 2y is equal to 6, for x equal to 0, y is 3. So this is 1, 2, 3. So we have the point here. And for the second point, for x equal to 2, y is 0. So we have the point here. We are going to join with broken line again, because the corresponding inequality sign is just less than, not less than or equal to. So we join the 2 points with broken line. So we have the line, and since this is less than, and for your information, in this situation, we don't just look at the sign and start shading. Before we check the sign, we need to check the coefficient of y, not coefficient of x. Please listen. We need to check the coefficient of y, not coefficient of x, before we embark on which of the side of the line we are to shade or which we are not to shade, which is the required region and which is not the required region. So since the coefficient of y here is positive, we are going to maintain this inequality symbol. Since the coefficient of y here is positive, we are going to maintain the inequality symbol. I repeat again, since the coefficient of y is positive, we are going to maintain the inequality symbol, which is less than. If it is negative, we reverse the inequality symbol and use. We are going to get that in the second problem of this video. So the symbol here is less than. Less than is the down part. This side is the required part of this straight line. So the upper part here is not required. And for the purpose of this video, we are shading the part that is not required. So we have it shaded. So this is for 3x plus 2y less than 6. And if you look at this now, within the graph, the required region is not shaded. So we label it R. And that R is the required region, which is represented by the inequalities given in problem 1. So with this, we are done with problem 1. We then go to problem 2. Problem 2, show the region which satisfies simultaneously the inequalities 2x minus 5y less than 10, x plus y less than or equal to 4, and 3x minus y greater than or equal to 0. Hence, find the integral values of x and y. So what do? Again, we are going to turn all the inequalities here to equation. Now we have inequalities in two variables here. We have x and y in one inequality, x and y here, x and y here. So what we do is we turn it to equation, create the table of values for each of them, then we draw each of the lines and then shade the region that is not required. Then we now have the required region unshaded. Probably it's going to form another plane shape. So we look at the first inequality, which is 2x minus 5y less than 10. So it becomes 2x minus 5y is equal to 10. Now for the second inequality, we're going to have it as x plus y is equal to 4. And finally, the third inequality, we have it as 3x minus y is equal to 0. So we now create the table of values for each of the equations we have here. For the first one, we have the table. This is x, y, and we are still going to apply the intercept concept to get the 2 points and draw the straight line. So when x is equal to 0, y is going to be negative 2. Since negative 5y is equal to 10, and dividing both sides by negative 5, we have negative 2. And then when y is equal to 0, this is gone. We'll be left with 2x is equal to 10. Dividing both sides by 2 at that point, x is equal to 5. So that is the table of values for the first equation. So for the second equation, we still have our x and y. And then when x is 0, y is 4. And when y is 0, x will also be 4. So we are done with that. And for the third equation, the table of value is this. When x is 0, y is also 0. Please, there's nothing like negative 0. So this is a special case. If you put x is equal to 0, it gives y 0. Also, if you put y equal to 0, x will still automatically be 0. So what we do now is to choose another value for either x or y. So we are going to choose y is equal to 3, which is the coefficient of x, since the coefficient of y is negative 1. So that when you take this to the other side, the 3 will divide the 3 to give x is equal to 1. So in order to avoid fractional values, you have to be very careful in your choice of either x or y, especially if the line is passing through the origin. We are done creating the table of values, so we go ahead to draw the lines. So we have our graph here, the x-axis, the y-axis. We then calibrate. You have to study the values of x. You have to calibrate. We're going to use 2 centimeters to 1 unit to represent both axes. So this is our origin. Here is going to be 2, 4, 6, and then negative 2. And here we have 2 and then 4. On the negative y-axis, we have a negative 2. Then we start with the first table here. So the first point is when x is 0, y is negative 2. When x is 0 is the y-axis. So where is y negative 2? This is the point. And the second point for that same table is when x is 5, y is 0. Or when y is 0, x is 5. So it is between 4 and 6, which is the midway. This is the point. We then join the 2 points. And what type of line are we going to use? It is going to be broken line because it is less than, not less than or equal to. Since it is just less than, we use broken line. Then we join the points. So we've joined the points. Then which of the side, is it the upper part we are going to shade or the down part of the line? So before we do that, we are going to inspect 2 things: the coefficient of y and the inequality symbol. So the coefficient of y here is negative 5. Because it is -5, we are going to reverse the inequality symbol. Since it is less than, we are going to make use of greater than. And greater than is the upper part of the line that is required. So the down part is not required. And I said for the purpose of this video, we're going to be shading the part that is not required. So we are going to shade the down part of the line, so which is for 2x minus 5y less than 10. So that is that one. We go to the next table. The first point there is when x is 0, y is 4. When x is 0 is y-axis, y is 4. We get the point. And for the second point, when y is 0, x is 4. When y is 0 is x-axis, x is 4 at that point. This is it. Then we are going to join the 2 points with normal or bold line because this is less than or equal to. So we join the 2 points with the bold line. So the next thing is to determine which of the side of the line. Is it the upper part we are shading or the down part? Is it the upper part that is required or the down part that is required? Two things: the sign of the coefficient of y and the inequality symbol. Since the coefficient of y is positive, so we are maintaining this inequality symbol as less than or equal to. So since it is less than or equal to, we are interested in the down part. So we don't need the upper part. Therefore, we shade the upper part of the line, which is not required. Then for the third table, we have the first point as the origin. So this is the origin. And the second point is when x is 1, y is 3. When x is 1 is this line that is halfway between 0 and 2. And if you go, the corresponding value of y is this point, which is 3. That's halfway between 4 and 2. So this is the point. We then join the 2 points. What type of line are we going to use? This is greater than or equal to. So we are going to use our normal bold line. So we join the 2 points. Now we check again which of the side of this line are we going to shade. Is it the upper part or the down part? Which part of this line is required? Is it the upper part or the down part? Two things: check the symbol and the coefficient of y. So the coefficient of y is negative and the symbol here is greater than or equal to. So because the coefficient of y is negative, I am going to reverse the inequality symbol to less than or equal to and make use of it. So our attention is less than or equal to. So for less than is the down part here, which means this is the region of the line that is required. So the upper part is not required. Therefore, we shade the upper part. So this region here, that's triangle, is the required region of the simultaneous inequalities. Then the other part of the question says, hence, find the integral values of x and y. So the integral values of x and y here means those points that their coordinates are whole numbers. If you check, there are infinite points within the required region, but the one we are looking for are the points whose coordinates are whole numbers. So to get the integral values of x and y, so we are going to look at it line by line with respect to x. So we look at x is equal to 0, which is y-axis. So the point here, since it is a bold line, so the point here is going to be considered, so we mark it out. Then here y is -1, so we mark that point out. This is y is equal to -2. The point is not going to be inclusive because this line is dotted line. So since it is not a bold line, so that point is not going to be included. Then we go to the next line, which is x is equal to 1. Now for x is equal to 1, so we start with the first point here. Since the lines that intersect here are both bold lines, therefore this point is going to be included among the integral values of x and y. Down here it is going to be included. Here is a whole number. This is on the x-axis. This is on y equal to -1. So the other points along x is equal to 1 fall within the region that is not required. So we are done with that line x is equal to 1. We go to x is equal to 2. For x is equal to 2, so this point here is inside the required region because this line is a bold line, so we mark it. This is inside, we mark, and also this point will be marked out. Then for x is equal to 3, this is the line. This point is inside the required region. This point is inside the required region, but this point is not inside. Then the last point we are going to look at is x is 4, and this is the integral point there. We mark it. Then we now list out the values of x and y for each of these. We then say the region not shaded gives the required region, and therefore the values of x and y within that region are, we have the origin, which is 0, 0. Here is 0, -1. So this point will give us 1, 3. Down here is 1, 2. Here is 1, 1, 1, 0, and here is 1, -1. So along this line, we have the point 2, 2. This is 2, 1, and 2, 0, 2, -1. So here this point is, here is 3, 1. This is 3, 0. And finally, this point here is what? 4, 0. And that is the end of solution to problem 2. This is the highest we can take in this tutorial. I hope you enjoyed it. Please like and share this video. If you have not subscribed to our YouTube channel, please do. Until we come your way again, goodbye.